Hello and welcome to C++ Weekly. I'm your host, Jason Turner, available for code reviews and on-site training. In this episode, I need to correct a mistake that I made in my recent episode about C++ 23's if const eval. Okay, so I recently covered the differences between if const eval, if const expr, and if is these three constructs, and you can go back and watch that episode, and I will try to put a link to it in the show here. Now, I stated that the main purpose for if const eval was to clear up some confusion about how to use if is constant evaluated. And apparently that's only the secondary motivation for why this feature was added to C++ 23. And I feel like the primary reason is, well, something I definitely should talk about. So let's just say we've got a function. So if I've got this and I'm saying if it is constant evaluated, then return 42, else return 24, and I've got my value that I'm getting from func here, and I'm returning value, and I have 24 returned because I did not assign the result of func to something that could be considered a constant expression. And there's some esoteric details here about core constant expressions that we won't go into at the moment. But if I just say this is const expr, now when I execute func, I am getting this branch executed, that is, if is constant evaluated, return 42, and now we see 42 is being returned from the program. This can be a little tricky to use correctly, and this was part of the point of the previous episode, that if I do if const expr is constant evaluated here, then fortunately our modern tools catch us and say this is going to always return true in an if const expr context. So what we have in C++ 20 is if const eval. And from the perspective of this code, it gives us the exact same thing. Now note there is no conditional here. It simply doesn't exist in this construct. Now I'm getting 24 returned again, and if I assign this to a const expr value, I'll go back to having 42 returned from the function func. Now, where things get interesting, let's go back to the is constant evaluated version. Let's say I've got another function, and this is just a simple const expr function, and I want to call get value here. Then I am still getting 42 returned as we would expect, and if I remove the const expr here, we should go back to getting 24 returned again, and we are, because it's not going through this is constant evaluated branch. Now, if I were to change this to a const eval function, which I've covered before, this is also known as an immediate function. This is something that must be evaluated at compile time. So let's go ahead and change this back to a const expr value, and we're expecting to get 42 back. And we are. So if we modify the code to look like this, where we have a parameter that we are passing to get value and a parameter that we are passing to func, and we are in this if is constant evaluated construct, and now we're passing in a 1. Now an immediate function, this const eval function, must be passed values that are known at compile time. Now this gets lost in the mix here, because we are doing a technically runtime check right here, although it is with a compile time known constant. The compiler is not able to trace for us and say, oh, well, okay, this is a compile time known value that we are passing to get value. So this is where if consteval should come in to save the day. Because this is now an actual compile time construct, not something that is runtime and is probably optimized away at compile time, but something that is actually a compile time construct. Now the compiler is able to trace this through and say, okay, this is a value that is known at compile time, so it is okay to invoke this immediate function. So if consteval was added in part to enhance composability between constexpr and consteval, also known as immediate functions. So a little bit convoluted, but a little bit of a correction that I needed to make on that episode to make sure that I didn't leave anything important out here for the motivation behind this feature. So thank you for watching this episode of C++ Weekly. You know what to do. Be sure to subscribe, share this video with your friends.